Assalamualaikum. This video is about chapter 2, elements, compounds, chemical equations and calculations. Okay, the objective for this chapter, first to define element, compound, atom, molecule and ion, and then to state the names or formula of elements, molecule and compound. And third, define proton number, nuclear number and isotope. And then to determine mole, relative atomic mass, relative molecular or formula mass, percent compositions, empirical formula, formula of compound and limiting reactants. And the last one is to form and balance the chemical equations and chemical stoichiometry. So for this video, I'm going to focus on first three objectives. First, we're going to look into the definitions. Okay, atoms is the smallest particles of elements that retain in the characteristic properties of the elements. So, this is an example. Okay, atoms of element X and atoms of element Y. Atom is the basic unit of an element that can enter into chemical combinations. Okay, and all atoms of a given element are identical. Okay, let's say this is atom element X, so they actually identical, having the same size, mass and chemical properties. And the atom of one element are different from the atom of other elements. So atom X is different from atom of element Y. Atoms are made up of three subatomic particles, namely protons, electrons, neutrons. Protons and neutrons are located at the center of an atom in a tiny core called as nucleus. So this is the analogy, okay, how the atoms looks like. So the outer layer of the atoms is made up of electrons. Electrons move around the nucleus in circular, and the orbit we call as energy level, and usually electron is negative charge. And while at the center in the nucleus, it made up of positive charge proton and nucleus. Neutron, which is neutron no charge. Atomic number is a number of protons in the nucleus of an atom of any particular element. Number of protons is equal to the number of electrons. And mass numbers actually the total number of proton plus neutron in the atom. So the symbol of the atoms or isotope is represented by this. Okay, so X is the atomic symbol, A usually the mass number, and Z is atomic number. So in the periodic table, so the to represent each of elements, each of atoms, so inilah dia punya bentuk. Okay. Okay, kat sini this is a periodic table, so you can say that dekat sini lah atoms animal, dia punya atomic number dengan mass number. Okay, next element. Element is a substance that cannot be broken down into two or more different substances. Okay, so same element will have same number of proton. So it is formed from the combination of atoms only. Okay, elements is actually the combination of atoms, and it also occurs in a molecular form in which the same type of elements or atoms are chemically combined. So they are called diatomic molecule or sometimes molecular elements. Example like hydrogen, okay, the form of more than one, which is diatomic molecule, hydrogen atom, nitrogen, oxygen, chlorine, bromine and iodine. Okay, so these are some common elements and their symbol. Okay, next is about isotope. So atom with identical atomic number but different mass number, we call this as isotope. So most elements have 2 or more isotopes, and isotopes have different number of neutrons. Okay, each isotope have similar chemistry, forming same type of compound and displaying similar reactivity. Okay, except that their atomic number is mass number is different. Next is molecule. So molecule is an aggregate of at least 2 atoms in a definite arrangement held together by chemical forces. Okay, molecules is actually a form from chemical combination of atoms. It combines in specific ratio to one another. Example, hydrogen gas, water, ammonia, and so on. Next, okay, ions. An ion is an atom or group of atoms that has a net positive or negative charge. Okay, so for cation, ion with a positive charge. So it means that the neutral atoms lose 1 or more electrons and become a cation. Okay, examples here, sodium ion, they have 11 proton, 11 electron, but if it lose 1 electron, so it becomes sodium ion, positively charged ion. So we call it cation. While an ion is an ion with a negative charge, means that if a natural atom gains or accepts 1 or more electrons, it becomes an ion. Example, chlorine. So they have 17 electrons, and when it receives or gains 1 electron, so it becomes 18 electrons, so it becomes negatively charged anion. So how the ion is formed? Okay, in any given atom, okay, the number of protons is always equal to the number of electrons. Okay, and the neutral atom can lose or gain electron and become charged. So the charged atoms are known as ion. Okay, they have mentioned before. So a positive ion, cation, when it release or lose an electron, while a negative ion or anion is formed when they accept an electron. So what happens there when sodium ion lose 1 electron, the electron will be gained or accepted by the chlorine ion. So that's why the sodium ion charge will be positive 1, while the chlorine ion will become negative. But when it come together, the total sodium chloride ions become natural. Okay. So the several monoatomic ion contains only 1 atom. So for one positive 1 charge, this is the list of the elements. Also the negative 1 charge, positive 2 and negative 2, positive 3 and negative 3 atoms that becomes ion. So for polyatomic ion, it contains more than one atom. Okay, example is ammonium. They have nitrogen and hydrogen ion. Means nitrogen, hydrogen atoms, and they become 1 ion, and it's positive charged ion. While carbonate, combination of carbon and oxygen, and have 2 negative charge, and it is an anion. Okay. So this is a common ion shown on the periodic table, so you can look by yourself. Okay, next, compounds. Compounds is a substance composed of atoms or 2 or more elements chemically united in a fixed proposition. Okay, compounds can only be separated into their pure components or elements by chemical means. Okay, an example here is lithium fluoride, quartz, dry ice. So this is a compound which is they are chemically united in a fixed proportion. Okay, next we're going to look one by one the chemical nomenclature or how we name our compound, element and ion. Okay, first, ionic compound. So usually made out of metal and non-metal. So anion is usually a non-metal. So when we name it, we add IDE to the element name. Examples here, barium and chlorine. So this is positively charged cation. This is negatively charged anion. So when we name it, barium, okay, the name of metal is the same, barium. For chlorine, since this is an anion, we need to add IDE for the name element name, so it becomes chloride. Potassium oxide, magnesium hydroxide, potassium nitrate. So this is a sum of equations. So please complete the name of the following compound and then you can discuss together with your lecturer. Okay. So transition metal ionic compound. So for transition metal ionic compound, so we need to indicate their charge on metal with Roman numeral. Okay. Here, so say we have iron and chlorine. So we have two chlorine. Chlorine is negative one charge, one negative one. So when become two, so you get negative 2. So iron will become positive 2 because this is natural, made out of natural, but each one they have same charge. So from here we can say that iron is actually positive 2 charge. So it become iron 2 chloride. So you need to indicate the charge in a Roman numeral. So this is the list of let's say the charge for monoatomic anion, okay, with their names. Okay, we need to add IDE in their names. So and this is the names and formula of some common inorganic cation and anion. So you can look by yourself, you can remember, you can hafal lah, okay, some of these elements, some of these ion name. Okay, these are questions. Okay, name the following compound. So you can try by yourself first and then you can discuss with your lecturer later. Okay, same as this one. And next is molecular compound. So how you name a molecular compound? So molecular compound usually made up of non-metals, only non-metals or non-metals with metalloids. So they have a common name. Okay, like here examples, we call this as water and ammonia. Okay, an element furthest to the left in the period and closest to the bottom of a group on periodic table is placed first in formula. And if more than one compound can be formed from the same element, we use prefix to indicate number of each kind of atoms. Okay, the last element name ends in IDE. So this is the prefix mean we use in naming the molecular compound. If you have more than one, so usually you use di for 2, tri for 3 and so on. So this is common example, hydrogen iodide. Okay, the last one we name is IDE. This is a nitrogen and we have 3 fluoride, so we name as a trifluoride. Okay, sulfur dioxide, dinitrogen tetrachloride, nitrogen dioxide, dinitrogen monoxide. So you can try by yourself in this question by naming the molecular mass. And also this question you can determine which one is the name of this each molecular compound. Next is a metal-polyatomic anion. So positive charge species on the left and negative charge species on the right. So for the positive charge we use stock metal or common name, while for negative charge species we use name of polyatomic ion and then we use parentheses as needed. Example of metal-polyatomic anion, example is barium. So we use the common name barium, and this is the sulfate polyatomic anion, so we name as polyatomic ions names. So barium sulfate, this is calcium nitrate, calcium nitride, iron 2 nitrate or ferrous nitrate. So this is the common name for iron 2 nitrate. So this is question. So match each set with the correct name. So you can try by yourself first, and then you can discuss with your lecturer. Okay. So here, next is for hydroacid names. So for hydroacid name, we put the hydro last halogen name, and the last at the end of the names we put IC. Okay. Acid which do not contain oxygen, example HCl, H2S, HF, are named by adding the hydro prefix to the root name of the element and then followed by the IC suffix. Okay, examples here, hydrogen fluoride, they become acid name is become hydrogen fluoric acid. Okay, the molecular name of HCS, hydrogen chloride, or acid names we call as hydrochloric acid and so on. Okay, and then it is some simple acid. Okay, if we have anion is fluoride, chloride, bromide, so the corresponding acid become hydrofluoric acid, hydrochloric acid, hydrobromic acid. Okay, next is for Oxo acid. Oxo acid is an acid that contains hydrogen, oxygen, and another element. Examples here: nitric acid, carbonic acid, and phosphoric acid. So for naming Oxo acid and Oxo anions, okay. So if you have per something acid, where we remove hydrogen ion from the acid, it become per nama of acid tu ATE. Okay. And then kalau acid tu lose one oxygen, so the reference it become IC acid. When they lose hydrogen, it become ATE. Kalau they lose another one oxygen, it become OUS acid. Okay, and then kalau dia lose hydrogen ion, it become ITE. And then kalau dia hilang lagi satu oxygen, it become hypo OUS acid. Kalau dia remove pula hydrogen, it become hypo ITE. Okay, the common example, this is the rules for naming isoanions, anion of Oxoacids as the follow. And the common examples is actually dihydrogen phosphate, hydrogen phosphate, phosphate. So how to name anions of Oxoacid? Okay, when all the hydrogen ions are removed from the acid, the anion's name ends with ATE. So from IC it becomes ATE. Kalau when all the hydrogen ion removed from the OUS acid, the anion names end with ITE, and then the name of anion in which one or more but not all the hydrogen ion have been removed must indicate the number of hydrogen ion present. Okay, kat sini sebabkan dia ada two hydrogen, so dia become dihydrogen. This is the phosphate. Okay, kalau dia lose two hydrogen, dia jadi hydrogen phosphate, and kalau dia lose another hydrogen become only phosphate. So ini example name of Oxoacid and Oxoanion. So ni is a common acid lah. Okay, macam tadi kita tengok one by one. Kalau dia perchloric acid, kalau dia remove one hydrogen, it become perchlorate. Okay, kalau chloric acid, okay, so bila dia remove one the hydrogen, it become chlorate. Okay, chlorous acid, yang ni dia makin kurang oksigen. Okay, mula-mula dia ICE per ICE, and then dia become ICE saja, and then dia lose oksigen lagi jadi OUS. So chlorous acid, bila dia remove hydrogen, dia jadi chloride. and this one is hypochlorous acid. Bila dia lose the hydrogen atau ion dekat sini, dia jadi hypochlorite. Okay, so the next, the mole concept and Avogadro number, I will going to discuss it in the next video. Thank you.